Creating a square with a volume of 2 with ruler and compass. Even though I'm not going to use a ruler and compass, I created or I made a square that you can make a fortune teller out of, right? So when I cut off the corners, you got this square right here. Let's say this square has the volume of 1, so 1 by 1 by 1 by 1, right? So if you take that square, right there, and do this, that you have the square, right? That's a square with half the area of this square, right? Easy, right? So if I take this and do that, and then I do that, I've created a square that has twice the area, which if we move these pieces right here, it's much easier to see is that square this is a square right here that has twice the area as this square. Easy. And since that square has this square has the area of 2, this square has the area of 1. And all you'd have to do to get the square with an area of 2 is to do that. So take a square, cut it in half from corner to corner, and then take that section. You take the edge of the square from that point, from there to there, and then from that point there to there, and then you've created a square with twice the area. And if this area was 1, that means this area is 2. And the importance of that is this with cubing, that this cube, when broken out, has one area by one area by one area by one area. So the volume is 1, right? So to say that, so I should be able to say that this cube that has the area of 2 will create a cube that has the volume of 2. And I'm pretty sure anyone could create this from ruler and compass, because ruler and compass is measuring of a point to point, of a point and a point, and then taking it from the center point and then measuring it. So this would be your hypotenuse, and this is a right triangle that's 45 degrees, which is a special triangle. So these legs are technically immeasurable, but this hypotenuse we know is 1 because of that. And what I mean is, if you go to this corner, well, I already showed that. If you go to this corner with that hypotenuse and then go 1 to there, and from there to there, that you've created a cube with twice the area. And just to hammer the nail in the coffin, this square is made with 4 pieces, right? So there's that one. That one. That one. That one. That created half the area of that square, which means I need 1, 2, 3, 4 more, which is what those pieces essentially are. And there's that. And there. But if this is making a square that has the volume from 1 to 2, what about a square that has the volume 3? And what that makes in difference is 1 by 1. So you make a second square and it goes 1 times 2 equals 2. And then you double those squares, it's 1 times 2 times 2 equals 4. And then now you do that with the square that has the area of 2. 2 by 2. So 2 by 2 means that square has the area of 4, which this one, or this rectangle has the area of 4 that this square has. And then 2 by 2 by 2, which is 8. So my question is, can we reconstruct a square that has the area of 3? And the point I do is 1 by 1 is 1 by 1 times 3, and then 1 by 1, or 1 times 3 is 9. So 2 times 3 is 6. 2 times 3 is 18. But then we go here, and 3 times 2 equals 6, 12, 9, 27. And this is 1 times 3, 2 times 3, 3 times 3. And there, 2, 3, or 2, 4, 3, 9. So this, and thinking about this gets really confusing for me, and that's why this right here is cut in half. Because if if that's how to get a square that has twice the area, so I cut that in half. The hypotenuse is there, there, and then I take that hypotenuse and go there, and then go there. So that's 1, 2, so 1, 2, 3, which doesn't quite make it there, but then I go there, which from what I can see, making a square with the area of 3 is more than likely impossible. But imagine how small of a triangle you'd have to make, since this is creating a square that's halved. So I'm halving the size of that square, and then this is having the size of that square. And then halving that square again, and then again, and again, and then is there a combination that will let me go from here to a little bit past here that actually gives me a square with an area of 3? That's my question. And from here to here with an area of 3, I'm not entirely sure. Well, thank you for listening. Bye.